So welcome everyone to the 2022 US-RSE virtual workshop, our second workshop in this way. And last year we thought it really went well. So we repeated a similar format this year. And yeah, make it happen towards a diverse and sustainable future is our theme. And please remember, we have the US-RSE Code of Conduct also for this event. And we will start now. So here, next slide. So this is a reminder for the code of conduct. So be empathic, respectful, welcoming, friendly, and patient, collaborative. And we are all careful in the words that we choose. And my experience in this community is from all the events that it is that way. So that is great. Next slide. So to make it all happen, so we have this workshop organization committees. So the chairs, Julia Damarov, also, maybe you wink in the camera. And I'm Sandra Geding. And we have technical program chairs who volunteered, Richard Abdil and Mahmoud Shad, and session moderators you will see throughout also in the workshop. So Daniel Howard and then Katz is also on. And the steering committee to help with decisions. Next slide. And reviewers who helped us to go through all the submissions. And so that is also very much appreciated. We know that is, besides your normal work. Next slide. So yeah, thanks not only to the committees, but also especially to the keynote, Damien Durson. I will introduce him a little bit more. And all the authors, presenters, participants who will make it happen towards a diverse and sustainable future. We had 16 submissions, so 13 for presentations, 3 for breakout sessions, and we accepted 10 of the presentations. And with that, Ian, if you go to the next slide, I think it's your turn.
That's me. Thanks, Sandra. So I was going to do this at the end, but I think I want to get it in first before I forget. A special thanks. It's not the same if we're not all in a room, but maybe some virtual clapping for Sandra and Julia, are the co-chairs for this thing. A lot of work goes on behind the scenes to put these things together, and you've done a great job. So thank you. This would not have happened without the two of you. Do it. So on top of everything else, you've managed to put this together. So great job. Thank you. So welcome everyone. My name is Ian Kazan. I'm currently serving in the steering committee here at US-RSE, and just want to use this opportunity to give a little bit of an overview, some updates, what's been happening. I've seen a lot of names I recognize, but a lot of ones I don't. So that's great. Welcome if this is your first event for US-RSE. We're glad to have you here. What is it we do? So we're a grassroots, community-driven organization, meaning we weren't funded by something. This was something that came out of a group of people who got together and said we needed an association around research software engineers, and roughly on this 4-pronged mission. So the first is to create a community of research software engineers. So doing events like this to get people together to share, connect, advocating for research software engineers, both the impact on research and the increasingly valuable role that RSE serve, providing resources. So this can be from DEI information to making the business case for why you should have an RSE at your institution or organization, up to training, resources, and professional development. And then diversity, equity, and inclusion. So this is DEI efforts, not just internally, obviously that's one part, but also promoting, encouraging this within the broader research software engineer community and profession. So we continue to grow. We don't have an active campaign to recruit, but people hear about us, they come and they join. So we're up over 1,200 members. You can see a map here. Apologies to folks outside the US. We're certainly welcoming to all, but you can see some hotbeds here and there, and some local regional groups popping up. That's a recent addition. So if you want to have a yellow dot on here, or if you see one near you, come over to Slack where most of the things happen, and reach out and see who's around you. So some new happenings. I'll cover some of the recent updates, and I want to stop talking so we can hear interesting things from Damien. Far more exciting. So Some recent developments, we've seen a growth of the internal working groups. So these are groups of like-minded folks who have a bit more targeted piece of, say, working on elements related to, there's DEI education and training that runs, looks at the website. I'm not going to go all over these. Point is, these hashtags are the channels in Slack. So come over to Slack, take a look. This is a great way to get involved, to kind of test your toes in it, to meet people. It's a pretty small commitment. All of these groups are sort of eager and welcoming to new members. It's a great way to contribute, get involved, meet some new people who have similar interests. New groups and initiatives are welcome. Obviously, we continue to grow and do interesting new things. So we had a monthly community call last week. We have them roughly every month to talk on topics ranging from, technical stuff such as testing frameworks and processes to things related to RSEs, such as, how to attract and retain RSEs. There's ways in community calls to propose ideas or come and just take a listen. These are usually almost always recorded. They're put on YouTube, but they're unlisted. So you're not going to find it from the YouTube channel. Go into community calls and there's links in there so you can see what you missed. A lot of times there's breakout sessions, which aren't recorded, but the beginning stuff do. And we're alternating the times here. I need a new picture. This one's pretty old. Some events that have been organized that are coming up. One we just missed, the DEI speaker series put together by the DEI working group. Had one recently. It's on the YouTube channel. If you missed it, you can go take a look over there. Next week, DEI Media Club is getting together to discuss this video. It's where you get together and reflect and discuss pieces on a particular media. In this case, it's from this talk by from Diverse RSE, what was that, a few months ago? Education training seminar series. So this is brand new. This hasn't been widely distributed yet. Keep an eye out in the next few weeks for official ways how to sign up to it on Agile Project Management for Research Software. So the education and training group is putting together a seminar series. And another one that's coming soon is a funder speaker series. So a chance to hear from and ask questions to different funding agencies on RSE related topics. There's some in-person events that are coming and some virtual ones as well. We teamed up with the Academic Data Science Alliance to do a fall workshop. And the intent of this is coming out of this is a guidebook for RSE and data scientist career paths in academia. Hopefully that'll help things. Next month, International RSE Day, probably something like a community call, eScience, SC. Keep an eye out for steering committee elections coming up soon. So if you're thinking about running, now's a good time to start thinking about that. But if not, just, we hope that members will take a look and, vote. Find out who you think is the best person for the organization and vote for them. We actively encourage you to do it. We'll have an AGM meeting or hear more about the organization. And another exciting piece of news, which Sandra's also behind, is a first in-person US-RSE conference in 2023 in October of next year in Chicago. So mark your calendars. It's exciting. It's happening. More information. Lots of opportunities for volunteers. There'll be calls for people to help it. It's only going to work if we get some many hands make light work, right? So we need more people to help and make this a success. I think this is a great milestone for not just the organization, but for research software engineers in the country. Also want to mention, we've got a job board. It's been blowing up recently. As of yesterday, there were 36 of them on there. There's a Google form to submit. So if you have one, Chad Doherty is lightning fast on these, but also a shout out to the others in the job post team, like Brian and Abby. Gets on in the jobs channel and on Twitter. And if you have a success story, please share it. We love to see these to find out that this is, you're finding your jobs from here. So with that, thanks everyone for being a part of this organization. We're always open to feedback, suggestions. Put them in Slack, email us. There's lots of ways to get a hold of us. We'd love to hear from you. We always do. So with that, I'm going to wrap things up. Ping me on Slack if you have questions. Otherwise, I'll hand it back over to Sandra, who will introduce our keynote. Sandra, over to you.
Thank you so much. And thank you so much again, Damien. So Damien Ruson, he's the group leader for the Computer Languages and System Software class group at Berkeley Lab. he is a mechanical engineer with experience in simulating turbulent flows in multiphase, quantum, and he leads the development of open co-arrays, parallel runtime library, and Smurf-Weiss partial differential equation solver framework. So his work at Berkeley Lab involves researching ways to accelerate predictions of climate change, regional impacts, teaching UPC++, and contributing to the LLVM Flang Fortran compiler. And this is also a fun fact about him. So his license plate has Fortran on it. And he lives in California and got it there. So that shows that he gets what he wants. So that is very cool. And with this, I give it to you, Damien, and many thanks again for being our keynote speaker.
Thanks, Sandra. This is a pleasure. I look forward to giving the talk, and just want to make sure everybody can see my slides now. Okay, good. So this talk is Black Lives Count Toward Accountability and Efforts to Diversify Computing. And give you an outline here. I tried to outline this in a way that sort of resembles a scientific talk with background and motivation, data analysis, solutions. So in some sense, it has a traditional structure for a technical talk, but in other ways, it's probably radically different from most of the things that we tend to talk about. So a little bit of background. This talk actually started as 4 slides at the end of my job talk in January of 2021 for this job. So you might ask yourself, why was I talking about diversity and inclusion when I was interviewing for a job to lead a group on computer languages and system software? So that's where some background helps. So I have a long background with Berkeley Lab, even though I just started working here last year in May. I first gave a talk at the lab back in around 2005, and then took an interest in joining the lab a few years later, and actually interviewed twice for jobs here, once in 2012 and then again in 2013, and didn't get the job either of those times. And somewhere along the way after that, I had a couple of conversations with a scientist who used to work here at the lab, who's African American. And I remember asking him if he knew any other African American scientists at Berkeley Lab. And he said only students and postdocs, nobody on the permanent staff. And that surprised me, but I didn't maybe think about it that much more until I heard that he retired. And he was about 50 at the time, roughly. So pretty early for somebody to retire. I was surprised by that. And it suddenly occurred to me that if he had been there long enough to retire, and he'd been there for quite a while, and if he didn't know anybody, there might not be anybody. And so I actually happened at the time to know the chief operating officer for Berkeley Lab. And I reached out to him and I said, hey, I'm not sure you guys have any Black scientists there. And he checked with the HR director, who checked the database and actually confirmed it. Now, staff scientist is kind of a unique title here. There are also a lot of people who are in a role called a computer systems engineer. In fact, in my group, we have a lot more computer systems engineers than we have staff scientists. But it's basically the PI role, and it's in many ways analogous to a professor in a university setting. And so, I had this kind of takes me back to this dialogue I had going in my head when I was in my 20s, when I would walk into a room, oftentimes maybe a classroom when I was in grad school at Stanford, and I'd look around and I'd be the only Black student in the room. And I'd often think, so that means that if I weren't here, there wouldn't be any African Americans here. And would anybody notice? And for a long time, that was just sort of this rhetorical question in my head that I didn't really think necessarily had an answer. By the time I was in my 30s, I had firmly concluded that the answer was probably no. And so how is it we get to a point that a DOE national laboratory doesn't have a single Black staff scientist and nobody notices? Like the COO has to check with the HR director, who has to check in the database to figure this out. So it brings the question, where is everybody? How do you get to this point? How do you get to zero? So that's why I was talking about this in my job talk. The job talk was why Fortran persists, experiences with teaching an underdog language, new tricks. And over time, I've expanded this into a whole talk, gave a similar talk at the PASC conference in Switzerland in June. And so that's what you're seeing today. And I've added a few slides since June. So even if you saw that one, there'll be a little bit of new material here. So more by way of motivation, I was really excited in April when the Biden-Harris administration announced a whole of government effort aimed at generating disaggregated statistical estimates to characterize experiences of historically underserved groups using survey data. And they wanted to increase non-federal research and community access to disaggregated data. So what do they mean by that? They're going on about disaggregated data here. So let's talk a little bit about my view on data disaggregation. If you look at the workforce data that Berkeley Lab puts online, we form these groupings where we have women, underrepresented minorities, which includes African Americans as well as Hispanics and Native Americans, other people of color, which includes Asians and Asian Americans as well as Pacific Islanders, and 2 or more races or ethnicity, and then white employees. So I would call this aggregated data, meaning that we've lumped these different groups together into these categories like underrepresented minorities. So one of the reasons you maybe don't notice what's going on when a certain population is now completely absent is because you've lumped that population in with other populations. And so I would say that we need to disaggregate this data to really understand what's happening. I was really excited when I first came to the lab because it was the first place that I heard this acronym IDEA: inclusion, diversity, equity, accountability. But if you think about the word accountability, and one of the root words for that is count, it's a little bit hard to argue that Black lives count if we can't count Black lives, right? So I would say that we really need to look at disaggregating our workforce data so that we can understand what's happening in various places. The good news is that the DOE labs are putting this information, a lot of information like this online, and some of them are disaggregating. So there's this one website, I should have the URL here. Maybe if there's somewhere that we're going to post these slides online afterwards, I'll include the URL so that everybody knows how to get here. But there are 17 DOE labs, 16 of them at least put workforce demographic data online. And just to give you an example of one that disaggregates, Argonne National Lab does actually break their data down by race. So I've been asking for this sort of information since I got to Berkeley Lab and still haven't gotten it. Oftentimes the explanations I hear are, well, if the numbers are too small, then you can identify, a person, you can figure out who is in that percentage, because it's 1 over, the number of employees in that division or something like that. I guess my pushback on that is when you get to the point that the number is 0, then whose privacy are you protecting by not putting this data out there? And so if we're saying that the reasons we don't disaggregate is because the numbers are too small, that's kind of like saying if the problem is too bad, we can't tell you, right? So fortunately, there are a number of labs that are disaggregating by race or ethnicity. I counted 6 by going through this website, 6 out of 16 listed here. So it's a minority. Fortunately, it's not a tiny minority, but I don't know what would make the difference between Berkeley Lab, for example, and one of these labs that does disaggregate. I assume they have the same privacy issues that we have. So let's think about the most common reason that people talk about why we have underrepresentation. People tend to jump right to the pipeline, right? And the issue I have with that is we generally hand wave when it comes to this. And we bring shockingly little rigor and data to bear on this problem, despite the fact that in all of our other work, when we're doing science and when we're doing research software engineering, so much of it is driven by data and driven by analysis. But when we talk about the pipeline, we just kind of throw the problem into the pipeline and say, we can't solve it, or we have to, get more kids in K through 12 to think about science, what have you. So let's actually look at the data on what's in the pipeline. So this came out in January. I guess actually, well, this says awarded in 2019. But this data just came out in January of this year. And if you average across STEM fields, mathematics, statistics, engineering, computer science, And actually, certainly in computing sciences, we're pulling from all these different fields. As was mentioned, my degrees are mechanical engineering, even though I'm in a computer science role here. Let's say roughly 3% of PhDs are African-American in these fields. Okay, so analysis. Pretty simple to think through what would be the probability of reaching zero, right? And obviously this is not hypothetical. I'm saying Berkeley Lab did actually reach zero at one point. Let's say if we just think about how it can happen just through random sampling. So if there's a 3% chance that someone you hire is African-American based on what's in the pipeline, then there's a 97% chance that they won't be. So you post a job, you hire, and most times, the overwhelming majority of times, it won't be someone who's African-American. I get that, makes sense. But if we're going to think of, if we're, scientists and engineers and we want to approach these things, in a more rigorous way, we have to think about the fact that by the time you get to the second hire, if you're saying these two things are statistically independent, you're now saying that if you didn't pick up one, it's really 97% of 97%, right? You've got to multiply the probabilities if they're statistically independent, okay? So let's carry that out a little bit further. By the time you get to 100 hires, even in a population where only 3% are African-American, there's only about a 5% chance that you wouldn't have found one just randomly. By the time you get to 200, about a 0.2% chance. By the time you get to, by the time you get to 300, I think it's down to around, let's see. It was 0.01 there, sorry about that. So what I would say then is that the odds against ending up at zero by random chance, the odds against that are astronomical. So we might as well take some inspiration from astronomy. Enrico Fermi, Nobel laureate in physics back in 1950, was talking with some colleagues and blurted out, where is everybody? In the search for extraterrestrial intelligence, if we assume that life is probable because it came up, pretty fast after the Earth was formed and reached the conditions where life, could happen, and there are lots of other planets out there orbiting lots of other stars, shouldn't we be able to see signs of life in other parts of the galaxy or the universe? But we don't yet. So where is everybody? And so to try and get at the answer to that, Frank Drake, who many of you probably saw in the news, just passed away this past week. I was fortunate enough to have a chance to see him speak. I saw him speak about 15 years, actually almost 20 years ago. I had a summer faculty fellowship at NASA, and at NASA Ames in Mountain View, California. And we got to go down to San Jose to the SETI Institute and saw him give a talk. And his basic idea, he formulated this in 1960, was we ought to be able to estimate the number of civilizations that we should be able to detect in our galaxy. And so the basic idea is we're trying to estimate that number in. And I will say that when I first saw this, it was a little bit confusing for me because I wasn't sure why there was a rate term in this. But thinking through it enough, I eventually figured out that the basic idea is that you're kind of imagining a pipeline where civilizations are coming into existence and sadly, possibly going extinct. So there's some length of time for which the civilizations are detectable. And if you think through it for a while, you can reason out that the number in the pipeline should be determined by, once you've reached a steady state, should be determined by the rate of star formation, times the length of time for which these civilizations release a detectable signal. You multiply that then by various other factors like the number of planets around each star. But then you have these other terms that you multiply by, such as the fraction of stars with planet, the fraction of planets that develop life, the fraction of planets that develop intelligent life, the fraction of civilizations that release a detectable signal. Okay, so a lot of science over the past 60 years or so has been driven by trying to come up with better and better estimates for these numbers. I would say that if you're searching for African-American terrestrial intelligence, then you're in a similar search and we can develop a similar equation. This fortunately came to me, I think it was actually the morning of my job talk. I had been thinking through that random approach to it for a while, and speaking with a friend who is an astrophysicist. He's now retired from UC Berkeley, Gibor Basri. He went on to become the vice chancellor for equity and inclusion. So he thinks about these issues a lot too. And when I was talking about the random analysis, he says, is that the right way to do it? I mean, the problem is we don't hire randomly, right? So it occurred to me that there ought to be some way to apply a Drake equation to this. And so this is what I came up with. Instead of the rate of star formation, we have the rate of African-American PhD graduates. And instead of the length of a detectable signal being released, we have the length of an average career, right? And so I group a few of these terms like, and then we'll also throw in the fraction of graduates in STEM fields. And I'm going to call those terms the pipeline, right? And the other terms I would refer to as the filters, right? These are the things we're doing that deterministically, right? So we basically have argued that you can't get to zero by random chance, okay? And if it's not random, it's deterministic. I think those are the only two options. That might be the good news. If it's deterministic, then we ought to be able to control it and affect it and make change, right? Let me step back for a second too and say that analysis that I gave applies to any room, anywhere, okay? I live in the state of California. As of about 20 years ago, whites were no longer a majority in California. As of around 5 to 10 years ago, I think about 5 years ago, no group is a majority. I'm sorry, whites are no longer the largest share even. Hispanics actually are the largest percentage in California. So if you walk into a room in California and there's enough people there to, get good statistics, and any group is in the majority, that room is out of skew with the population of this state. And the larger that room is, the less likely it could get out of skew by random chance. There are deterministic forces that are causing this, okay? So the fraction of African-American STEM graduates who apply for your positions, the fraction of applicants who match specific technical / project / programmatic needs, the fraction of applicants who meet some measure of merit. So, in my job talk, this was, I think, the final slide. Actually, I only had 4 slides on diversity. And I said, I'm not going to carry this analysis far enough to plug in numbers for you. But I will tell you that my working hypothesis is that if you do plug in numbers, you're going to have a hard time justifying zero. Okay. But once we have an equation, it gives us a way to frame the discussion, because now we can talk about some of these filters and what are the things that we can do about them. Okay. Solutions. Let me also just check in. So I think we were planning for me to start at 10:10, which would mean I'd finish at 10:40. I think I started it more about 10:15. When would you guys like for this to wrap up?
So you have still a time, like another 5-6 minutes more.
Okay, good. So what can we do about some of these filters? The fraction of African-American STEM graduates who apply for positions. Well, we do a lot of hiring through our networks, right? And so expand beyond our networks or diversify our networks. I'll talk about a program that does that. Go where the underrepresented populations are overrepresented. I was so excited earlier this month to attend an AI for Science workshop that was held by DOE, where about 200 researchers came together to talk about, I guess, plan for where we'd like to see AI for Science going, and to be able to come out with a report that advises DOE on that. And we held that workshop at a historically Black university, Bowie State. And we involved that university. They actually calculated that something like 11% of the participants in the workshop were from the university that hosted it, okay? We need to go where the underrepresented groups are overrepresented. The fraction of applicants who match specific technical needs. So a lot of hiring, in my observation at government labs, I've been at 3, the Naval Research Lab, Sandia, now Berkeley Lab, a lot of the hiring is driven by project needs. That makes it very narrow in terms of who we can hire. And somebody just highlighted something on my slide here. I don't know if that was on purpose or not. So what we did at Sandia was we put together an early career LDRD program. LDRD is Laboratory Directed Research and Development. It gave managers a pool of money they could tap into for 2 years to just go out and find the best talent they can find, not depending on project money, so that the people they hired would be funded for 2 years. And these were not postdocs, these were career staff hires. And it was done with an eye towards diversity and inclusion. I hired someone when I was at Sandia on that funding, Carla Morris, who just made Distinguished Member of Technical Staff at Sandia. So she's had a distinguished career there. I was in the combustion research facility. She had written a dissertation on turbulence in superfluid liquid helium, a phenomenon that occurs only below 2.1 Kelvin. So the opposite end of the temperature spectrum from combustion. But she was stellar. This is a woman who, Black, Hispanic woman, and at one point when I first met her was undocumented and has gone on to a phenomenal career, but there's no chance that I could have hired her if it had to be tied to project money. The fraction of applicants who meet some measure of merit. When I was talking to the professor I mentioned on campus, and he said, yeah, I've thought about doing the kind of analysis you're proposing, but I was always worried that if I did it, maybe I could justify 0, right? Because we're looking for 3 sigma people. Well, that's easy to say, but 3 sigma is a precise statement. So if you're going to say something like that, the first question I'm going to ask you is, what's the random variable you're talking about? Second question I'll ask you is, do you have data that shows me that everyone you've hired for the last several years is 3 standard deviations above the mean in that random variable? The third thing I'm going to ask you is that if you can do that, do you have data that shows that random variable is predictive of future success in your organization? Because if you can't do all these things, I'm going to call BS. And that was actually the end of my job talk. Somehow they still hired me. I was talking with a friend who's the president of the National Society of Black Physicists, and he pointed out to me that what I was saying here was not new. Even at Berkeley Lab, there was a scientist, Keith Jackson, who wrote an article back in 2002 saying largely the same things. Like, we go out and have these K through 12 efforts where we bring kids in, to talk to them about, did we skip over? I skipped over a slide here. To talk to them about science. But if they don't see that there's if you bring in a bunch of Black kids and they don't see that there are any people of color here, then they might conclude that this isn't really an option for them. But most importantly, what he was saying, I'll just say quickly, was this is not a pipeline issue. There are people in the pipeline that we're not hiring. And what was he saying about what we can do about that? Things like summer programs. This is getting back to diversifying our networks. So a summer program that I'll mention, hopefully many of you have heard of it by now. It was pioneered at Berkeley Lab. It's called Sustainable Research Pathways. They've now taken the show on the road, and there are 8 labs involved in the newest version of it, which is SRP for HPC. And what this does, I call it speed dating for research. Lab staff present the work of their group. Faculty and students from a very diverse array of colleges and universities present their work, and we try to match. And through SRP HPC, since it was funded by the X-Scale Computing Project, ECP, if a match happens, ECP funds them to come in for a collaboration over the course of the summer, and you don't have to tap into your project funds. I had 3 people work with me this summer through the SRP HPC program. 2 were Hispanic, one a professor and his undergraduate student from Northern New Mexico College. I had never heard of Northern New Mexico College until I met them. A third was an African-American student from San Diego State University. So the goal here with SRP HPC, led by Marianne Leung, who leads the Sustainable Horizons Institute nonprofit, is to diversify our networks and hopefully thereby diversify our hiring. So I think I have about 3 minutes to go here. Last few things I'll say. This is also getting towards a solution, but I need some time to set it up. So I'll set it up by saying a diverse workforce does work differently. This is a great book that my partner and my son gave me for Father's Day a few years back. It's The Jazz of Physics by Stephen Alexander at Brown University. He's an African-American physicist. When I first saw the title, it seemed a little bit backwards to me. I'm used to seeing books like The Physics of Jazz, and they'll talk about a vibrating string and acoustic waves and what have you. No, this is about the jazz of physics. It's about the fact that he's also a jazz musician, and he goes to jam sessions and the music he hears inspires his physics theories. That might sound kind of hokey until you read the book, and he's got quotes in there from 2 Nobel laureates. Abdus Salam was one who at one point turned to a Black PhD student at the time, Jim Gates, and said, you know, one day when your people do physics, it will be like jazz. Albert Einstein, another quote in the book, said, it occurred to me by intuition, and when he was asked about his theory of relativity, he said, it occurred to me by intuition, and the driving force behind that intuition was musical perception. So 2 of the top physicists of all time are telling you that there is an analogy between the way they see physics theories being developed and music. Now connect that with the fact that Stephen Alexander is performing music from an African-American tradition. That therefore tells you that even physics will be done differently when we have a more diverse group of people doing it, right? I would also say that a diverse workforce does different work. This is from an article that a paper that I published at the Collegeville Workshop 2020, and it also then became a blog post on the Better Scientific Software website, where I talked about the fact that as an African-American, I see my adopting an underdog language, Fortran, as partly being an extension of being outside the dominant culture in STEM fields. At a time 20 years ago, when most people who were passionate about improving scientific software development were adopting other languages, I found that an ability to embrace difference and combat stigma along one obvious dimension, I'll say race, makes it feel natural to swim upstream or outside the mainstream along another dimension, programming language choice. So guess what? You finally get a Black staff scientist here. That might mean you're going to be doing Fortran for the first time. There was nobody else around here doing Fortran, okay? We will be doing different things technically when we hire a different population of people. And those 2 things, I hypothesize at least, are related. Really important to recognize that, and I'll wrap up, got, I think, maybe 2 or 3 more slides here I'll run through quickly. I won't have time to talk about this one in detail, but I presented it, or I didn't get to present, but I had an accepted position paper at a workshop in December that talked about programming language bias. It's really important to recognize that programming languages are human languages. You write source code for other humans to read. Sometimes that other human is your future self. You're not writing it for the computer. If you're writing for the computer, you could just write 1s and 0s and be good to go, okay? Just like there are biases that come into play in spoken languages, there are biases that come into play in programming languages. And we need to address those if we want to have more diversity in our workforce. You can see it come out when you see in the published literature, people saying things like, Fortran, the infantile disorder, by now 20 years old. This was written back in the 1970s, and I found it in a course syllabus from 2001. You know, how would you feel if someone described your life's work? I mean, I'm most known for my work in Fortran. I gave the keynote address at the International Fortran Conference last year. How would you like it if someone described your life's work as an infantile disorder? How does that feel? You can write Fortran in any language. That's a common thing that software engineers say. It's their way of saying you can write bad code in any language. Fortunately, I think we're turning a corner in some ways. I found this one article where someone said real programmers write Java like Fortran. So maybe they're acknowledging that, you know, this was actually saying it's a good thing, I guess. I just want to point out there's data here. I'll put these slides online. Fortran is not going anywhere. It's not gone. It is still very much a language. This is actually not even human surveys. This is looking at runtime data. What are the runtime libraries on the top platforms at the NERSC Supercomputer Center? This is from 2014 through 2018. And they can detect that Fortran is neck and neck in the latest data from Corey in 2018, neck and neck with C++. Somebody tell me that Fortran is dead. Rumors of Fortran's demise are greatly exaggerated. I think this is my last slide before the conclusions. Just want to mention this concept of intersectionality. It was first popularized by Kimberly Crenshaw, who's a UCLA School of Law professor. This article where she, you know, I don't think she's the first person to invent this concept, but this was the article that I think that really made the splash. When I checked a year ago, the article had 21,000 Google Scholar citations. When I checked last night, it had 27,000. This is an article from the 1970s. It's had 6,000 citations in the past year. Talk about impact. What she was doing was looking at what happens at the intersection of two groups that experience discrimination. And it's really interesting. What happens there is not just double discrimination, it's actually things that are unique to that intersection. Okay, so I think a lot about this because I'm a Black guy writing Fortran. And what she was getting at is, she was looking at a case where a company was being sued for discrimination by a Black woman. Unfortunately, the court threw the case out because Black woman is not a protected class. Black is a protected class, but the problem is the company was hiring Black people. It's just they were mostly hiring males into jobs that were manual labor. Woman is a protected class, but the problem is the company was hiring women, but they were mostly white women in front office jobs like receptionists. So if you were a Black woman, you're out of luck, sorry. Things happen at the intersection that don't happen elsewhere. My recommendation is resist the juggernaut, okay? We see things like one parallel programming model that's used in over 90% of parallel programs. That's a juggernaut. That's a problem when we have other parallel programming models like CoLRae Fortran, where I don't have time to go into the details, but I can show you outperforming MPI. Even when the CoLRae Fortran is supported under the hood by MPI, it's still better MPI than you would have written yourself. Or GasNet EX, a competitor to MPI. We can show you better performance. Why is it that 90% of codes are still using MPI? So Black lives count, but only if we can count Black lives. We've got to disaggregate the data. The odds against a significant difference from the pipeline happening randomly are astronomical, folks. We don't get to this situation randomly. It's deterministic. The good news is if it's deterministic, we can solve it, we can change it. And there are solutions out there. I talked about the SRP-HPC program. A diverse workforce does work differently and does different work. Programming languages are human languages. Bias can be intersectional. Inclusivity requires a diversity of thought. We've got to combat stigma. I can't tell you how often I'm at a workshop or conference. Just at this AI workshop I went to a couple of weeks ago, I'm glad we were at an HBCU, but someone stood up at the meeting and said, okay, so we're all doing modern programming these days. We're writing C++ and Python. Guys, half the cycles on the top platforms are still Fortran. The definition of writing modern code isn't we're writing C++ and Python. There's modern Fortran too. We've got to combat stigma. We have to resist juggernauts. Okay, hope I haven't used up all the time. I can take questions if there's any time.
Thank you so much, Damien. So this was a fantastic talk. And I let you talk longer because we had the comments that everyone was like, no, don't interrupt him. Let's get it on.
Okay.
So I didn't interrupt you anymore after I gave you only 5-6 minutes.
Thank you. Sorry about that.
I told you I would interrupt you. I didn't do it. So, but it's open for questions. I only wanted to say, so the official break was planned from now for 15 minutes. Let's go into the break a little bit. I think we can afford to start maybe then a little bit later or have only a 5-minute break. So please, everyone who has a question, put it in the chat room or raise your hand. Speak up, whatever you prefer. And we got one comment in the chat. Devastatingly important talk. Thank you, Damien from Peace Baby. So, any questions? So I have a question. Oh, sorry, David.
Hi. Thanks. Great talk. 2 questions, which might be completely unrelated. Totally hear everything you're saying about, being able to count. And then at the end, you talked about intersectionality. And we know that, race is real, but it's a concept that's been used to control and repress people. And the way we measure race has changed. The way we even take like surveys and the way that we make these categories has changed. So like, can you say a little bit, is there a way that we can make sure that we are counting people and make sure that we're not just like reinforcing these existing categories? And is that, do we need to like, have more dimensions? And then just unrelated, but since you brought it up, that I recently found out that there's a book, I was trying to look it up really quick, about like how to write good APIs for scientific research. And it's all based on Fortran. I'll look it up and I'll put it in chat. And I wondered if you could say a little bit, since you're talking about like, let's not just embrace the juggernaut. Do you think that there's like lessons learned about a good way to write in Fortran? Do you see like commonalities? Should we, are we all sort of like reinventing the wheel in sort of like trying to write, like domain specific code? I don't know if that question's clear, but
Sure, yeah. So the first part of your question, I too worry that we could just put this data out there, and then it's like, oh man, that's depressing, but not necessarily go deeper. So I think what we really need to do is we have to bring the same level of rigor and data to this discussion that we do to the rest of our work, right? So we've got to go deeper. It's not just about showing that there aren't enough African Americans here. We need to do further analysis. So I'm very fortunate to have an ally, Deb Agarwal, who's a division director here at the lab, who, because I've been pushing so hard for this, went out and got more data. And so she just presented this for the first time a couple of weeks ago at a meeting of an all hands meeting for 2 divisions here at the lab. And the data that she gathered showed that if you look at the distribution in these same groupings, underrepresented minorities, other people of color, whites, in terms of our qualified applicants. So this is just the pool of people that managers have designated as being minimally qualified for the position. And these are the people that we will at least consider, do a phone screening, interview, what have you. It turns out that when you get from that to who we hire, both the underrepresented minorities and the other people of color, which is Asian Americans, Pacific Islanders, both take a hit. There's a drop in 20% for African Americans from the qualified applicants to the hired. There's a drop of like roughly 33% for Asian Americans, Asians and Pacific Islanders, from the qualified applicants to who we actually hire. It's really interesting when you see this kind of data, because in the public dialogue, we're hearing about like, there's a lawsuit, I think, pending before the Supreme Court right now about schools like Harvard discriminating against Asian American people. And these lawsuits are typically blaming affirmative action, which benefits the underrepresented groups. But our data shows that what's happening here is both groups are taking a hit. And the one group that's benefiting is white applicants, going from like 41% in the qualified applicant pool to 57% in the hired pool. So we've got to go deeper. We've got to, do a lot more analysis, not just stop with this group's woefully underrepresented. Then your question about Fortran. So I mentioned I gave the keynote last year at the International Fortran Conference. And I talk a lot in that about programming patterns that I recommend. I've developed a way of doing functional programming in modern Fortran. And I talk about several different programming paradigms and how one supports another, sometimes 2 combined to support a third. So you might check out that talk. I haven't unfortunately had a chance to publish that in a paper just yet. Sadly, this was a talk that I gave remotely because the whole conference was virtual a year ago, and my laptop battery died in the middle of the talk. So it took me about 6 minutes to recover. I switched laptops. I downloaded the PDF of my slides from the conference website, and I got going again. But So there's a 6-minute gap in the middle of the video, but otherwise I'd recommend checking that one out for my take on how to write modern Fortran using Fortran 2018.
Cool, thank you.
Great, thanks. So I think we had a couple of more comments, and of course, thank yous to you, Damien.
Sure.
I don't see a direct question. So, but I would have a question. So when you talk about, bringing out the numbers also more there, and that it's not only the pipeline. So the numbers, let's say, for example, I work for the University of Illinois, and Chicago is also a minority serving institutions. So they reflect that they have a high partial, in students, but it doesn't continue then with PhD students in that same ratio. What do you think? What is the reason then for that? That even if the pipeline seems to be okay with the undergraduate students,
Sure.
that it doesn't continue then for
Yeah,
the institutions.
it's a leaky pipeline. I mean, given that I'm not a social scientist, I can't say a lot about this broadly. I can say my experience, and I can also maybe, quote a social scientist. One person I'd recommend whose work I recommend reading is Claude Steele. He's probably emeritus by now, but professor of psychology at Stanford, and he also was at Berkeley for a while. He's done a lot of great work on underperformance of various groups. Now, when he says underperformance, what he's saying is, for example, you might look at a cohort of high school students with certain incoming indicators, SAT score, high school GPA. Based on that, you should be able to predict with some level of accuracy what their graduation rate would be, what their graduating GPA would be in college. And what's happening is there's a phenomenon where, students from underrepresented groups are underperforming their peers who come in with the same statistical indicators, right? So there's so much discussion in the public debate on these topics around affirmative action and around lowering our standards to, get certain groups in. What you see when you look at the data is, it's not so much about lowering our standards, it's even when we bring people in with the same statistics, we're doing something to screw them up once they get here. The problem isn't them, it's us.
Yeah, I'm totally with you there. Yeah.
One of the things he talks about is connectedness. So I'll just say that it matters a lot. I had a really, really amazing PhD advisor. I would not have made it through my PhD program without him. Connectedness matters a lot. Feeling that you're part of whatever department or research group you're in.
Great, thank you so much. Yeah, the sense of belonging, Caleb says that also is huge. I think, yeah, I would like to follow up with you also offline. I have a research project on user preferences, why students see content for curricula differently. So that might be interesting, yeah. So because of the time a little bit, so we have 4 minutes left of the break.
Sorry.
No, honestly, people wanted to hear it. We wanted to hear it. That is a good sign. When people start to skip their breaks to hear you speaking, that is fantastic. So thank you very much again. Also again for, jumping in the last 12 hours. Very, very cool. Thank you so much.
Okay.
So it's my pleasure to share the next talk session. We have 3 talks, and we will start with Patrick Schmitz and Shavak Chaudhary, understanding factors that influence research, computing, and data careers. Take it away.
Okay, thanks. Everybody see the slides?
Yes.
Great, thanks. So I'll admit it's a little daunting to follow Damien. It's quite a talk. But I also really appreciated some of the things he was talking about that we're actually trying to go after as well. So first, welcome on behalf of our co-authors. Just a little bit of background. I started out actually as a software engineer working on projects ranging from video game development to real-time software for video editing and special effects. currency forecasting systems, applied NLP for semantic search, museum collection support, and eventually digital humanities research. I ended up shifting to team leadership over time and now do strategic planning and professional development for the RCD community. So I feel a lot of connection to the RSE folks. And Shafak, do you want to introduce yourself?
Sure. So hi, everyone. I also started as a software engineer working for a couple of multinational firms. I still remember one of my jobs, that company, they had never ever hired a female software engineer before. So that was quite an experience there. And in the US, while pursuing higher education, I continued working part-time as a programmer. And then later on, I became the manager for the programmers team. And now I serve as the director for research technology at the University of Central Florida. So it's a strategy and policy facing role.
Cool. So for those of you who don't know about CARC, which is the organization within which we're doing some of the work that we're presenting, it's an organization that advances the frontiers of research by improving the effectiveness of RCD professionals, including their career development and visibility, and their ability to deliver services and resources for researchers. So it's much like RSE for the broader set of RCD professionals. And when we say RCD, we use that as a really broad rubric, and it includes a whole range of different things, including the different tracks you see there that are the People Network, which is a discussion forum, sort of a year-round conference. And you'll note in particular that for the software related issues, we do point people at RSE because of all the great stuff that you guys are doing. There are a number of working groups at CARC, including the professionalization and career arcs groups that are doing a lot of work around exploring the demographics and understanding decisions that impact people's careers. But there's also other groups doing the capabilities model, which is just an assessment tool for programs, and a couple of interest groups working on things like staff and student training programs. So the larger context of the work that we're talking about today started about 6 years ago, actually, with a series of meetings and workshops that recognized the need to support folks doing the kind of work that we all do. We ended up coining this facings term to describe the different roles involved. And I'll talk a bit more about that in a minute. A series of workshops then led to the development of things like an HR job family matrix that's used by more and more universities. And more recently, several surveys to understand the demographics of our communities, getting to that counting that Damien was pointing out is so essential. And then we also were looking at factors that influence career path decisions. So we really encourage you, if you're interested more in some of the things that Damien was talking about, to look at the PERC 22 paper that was related that's on a census of the RCD workforce. So I mentioned these facings, and before we dive into our results, I want to describe what we mean by this. It's a concept that's broadly used within CARC at this point, and it's really just describing people and roles, not individuals, but roles more, because many of us wear several hats, in terms of the kinds of things you focus on. So we talk about researcher facing for folks that are doing direct research engagement, data facing for things like RDM specialists, data librarians, and scientists. The software facing is primarily research software engineers, but also includes some folks that are doing other kinds of software work, for example, in HPC environments. The systems facing is probably the best understood, systems engineers, storage, network engineers, folks like that. And then the strategy and policy facing, which is really around leadership and management. So that's just how we describe the roles, but we recognize few people wear a single hat. And depending on the size of the organization, you may have people that specialize in one or that have to cover everything. So the motivation for pursuing this really recognizes that our profession has several challenges. And while we mention this in the context of RCD roles broadly, the same things applies in the RSE world, we know. There's a critical shortage of our workforce and people capable of doing this. There's just not enough people to fill the needs of the research, computing, and data profession to support the advanced research that depends on this workforce. Recruitment challenges are a big issue. We don't know where to find some of the people that we could recruit into this. Recruiters don't always know how to market or where to market these things, and how to really make it sound compelling in many cases. And then we have retention challenges that include the lack of well-defined career paths for people. So when we pursued this, we had one of our partners, Kurt Key, is a professor who really looks at organizational studies. And we were thinking about this idea of organizational socialization, which is defined as a learning and adjustment process that enables an individual to assume an organizational role that fits both organizational and individual needs. So it includes a series of steps ranging from pre-entry, where you want to understand what attracts talent to the field so that you can better market to them. The entry phase, where you really want research-based information on talent pools for hiring managers to really effectively recruit these folks. A metamorphosis stage, which ranges from onboarding new folks to motivating them to stay and grow, which is really that retention point. And then looking at exit, what is it that drives people out of the field? And so the aims here are to help recruiters market these positions, help hiring managers recruit and retain, highlight the possibilities for future workforce, and really the paths available to the existing workforce. So we had a standard IRB approved research model for this. And you can read more about this in the paper. We devised a survey of about 31 questions. It was distributed to a range of different folks. It ran from November 21 through January. And then we did our analysis and submitted our initial findings to PERC 22. So when we were looking at the data, and you can read more of the details about this in the paper, but we really were interested in a couple of key areas. How well did people understand this field and what relevance experience they thought applied to it? What were the things that they thought were important about getting access and getting into roles in RCD? And then what were the things that motivated them to change jobs within RCD or to leave this world altogether? And in looking at that analysis, we considered three lenses: where they were in their career, early, middle, or late, the gender and how that impacted, and then roles. And we don't have time for everything today, but we do want to look at the roles in particular, focusing on software facing and what was distinctive about them for this community, and gender as well. So this is a graph that just shows the distribution for those who reported that they have a software facing role. So that's most germane for the community. It's here at the workshop today. And as you can see, the software facing respondents skewed heavily to those with less than 10 years of experience, but it does include a fairly broad range altogether. The curve for the total set of respondents is pretty similar. It was just spread out a little bit more. So we asked, how important were the following factors in your successfully pursuing research and computing RCD opportunities? So we let them rank 17 factors that ranged from demographics to skills and capabilities. And so here we see the top three, and it's not surprising that the top two are technical skills and experience in academic research, although we did think it was interesting that interpersonal communication was ranked number 3. There was a whole middle set that ranged from training and experience to referrals and things like that. And at the bottom of that set is leadership skills, which I want to come back to in a minute. And then we'll note that for software facing folks, certifications were not highly valued, and folks didn't believe that age, gender, or racial identity were major factors in getting jobs. And I will say that the ranking of that latter thing may well be a function of a largely white male population that responded to the survey. I think people don't acknowledge what impact that has on getting jobs. So when we then asked, what does advancement in your current RCD role mean to you? And this is how factors were ranked by folks who identified as software facing. And I would note that factors related to leadership, like having influence and making an impact, are rated quite high, although people didn't consider them that important in getting a job. So there's an interesting contrast as well between factors that are related to leadership, which is, as we say, are rated quite high, and factors that are more in the domain of management, in which are actually rated quite low. And I think this may partly reflect a distinction between research-related roles, like research software engineers versus traditional IT roles. given that the culture of research organizations tends to be less structured and hierarchical than enterprise IT roles. When we look at that same question for all facings, and here each of those colors represents one of the different facings, and this graph just shows the top and bottom factors, the most highly and lowest rated factors. We'll see that in general, the software facing is pretty consistent with what the broader range of folks had to say. All folks in research, computing, and data roles care most about recognition and impact, although salary is clearly important. And they generally care a lot less about factors that are valued in more traditional or enterprise IT roles. I just think that's interesting. We also asked how important were a set of factors in motivating you to make a previous job transition, or that would motivate you to consider a future job transition or within the RCD field. And for all RCD roles taken together, there's an interesting contrast between seeing higher salary as one of the highest signs of advancement and a relatively lower ranking of salary when shifting from one RCD job to another. And while this is somewhat less pronounced within software-facing roles, than overall that same pattern holds. We then asked how important were each of these factors in motivating you to leave an RCD role for something in a domain outside of RCD that is, leaving RCD, or that might motivate you to. And the top two were about salary and stability of funding. And it's interesting that the number 2 factor was a loss of funding, because in the previous question on moving to another RCD job, this same factor had a very low ranking. So the loss of funding isn't a factor for moving from one RCD job to another, but it's a major factor for leaving RCD altogether, for example, moving to industry. The next set are mostly about organizational and job satisfaction issues. Of note, people are not leaving RCD roles because they're excited about moving into industry. And again, the ranking of the software-facing folks is largely consistent with what we saw in other areas. Some of the things that we noted that are kind of interesting for folks that are interested in moving up into leadership roles is that progressing up a series of titles it was more important to folks in software-facing roles than we did see for folks in data-facing and system-facing roles. So that's kind of interesting. And then the distinction between strategy and policy-facing roles show that folks in those roles are less interested in developing deep domain knowledge, acquiring new skills, and becoming a senior contributor, but they're more interested in things like organizational influence, funding, growing a bigger team. Interestingly, community engagement was high for them, and opportunities for advancement and culture of innovation. Okay, so I'm ripping through a lot of this stuff. There's more detail in the paper. And now I want to transition and let Shafaq talk a little bit about what we saw with gender in this data.
Thanks, Patrick. So for the gender lens, we wanted to see if, whether gender does play any role whatsoever in these factors that we analyzed in our study. So as far as demographics were concerned, we had 225 respondents. Of those, 58.5% were men, and 34.6% that identified as women, 3.8% non-binary or other genders, and 3.1% chose not to disclose the gender. And, as per some other studies as well, we noticed here that although we have representation of the genders in all the different facings, but for the system and software facing, we see there are more men than women who chose this facing. And in fact, if we were to zoom in on the software facing, we can see that of the respondents that did select this, there were 26% women, almost 70% men, 2.2% non-binary or other genders, and the rest were 2.2%. So coming back to those research questions that we asked. So the question was, what does career advancement mean for the different genders? Do they give importance to different factors when talking about advancement? And what we saw is that women, they consider recognition and impact to be far more important than compensation, whereas men, they rate both compensation and impact to be equally important. Additionally, we also see that the non-binary, they rated recognition and influence on organizational strategy as equally important. And so then that was higher than compensation. So these were the slight differences between the advancement. And next, we wanted to look at the importance of factors that people think help them in successfully landing their RCD positions. And here, we already covered what the top 3 were in the previous slides, but when we look at the different genders and their responses, we saw that women consider that their interpersonal communication skills, their leadership skills, and referrals from others help them to land their jobs. Whereas men stated that it was the technical skills, the types of projects that they worked on, as well as the number of years of overall experience that they had, both in and out of RCD. And the non-binary respondents, they ranked experience in the academic research and interpersonal communication as important factors for them successfully landing their RCD positions. So we wanted to see if there is any difference in how hiring managers pay importance to these factors when they are looking to hire candidates into the RCD positions. And when we saw what the top factors were, the topmost was technical skills for all hiring managers, regardless of gender. And this was followed by interpersonal skills and the experience in an academic research environment. Additionally, we saw some interesting differences where for women, in addition to interpersonal skills and academic research experience, the female hiring managers, they actually look at technical certifications and consider that to be an important factor when they are looking at hiring candidates into RCD positions. Whereas the male hiring managers, they pay importance to the referrals from others, as well as any experience that the candidate had working with an RCD group as a student. So looking at the factors that motivate job changes and looking at it from the gender lens, for everyone, the factors that motivate them were the opportunity for a more meaningful contribution, professional skills development, joining an innovative organization. But the interesting observation we made were related to the women and non-binary. And for them, we see that they are motivated to find a team that is a better cultural fit. And additionally, the non-binary also consider that lack of motivation is a factor that would motivate them to change jobs, as well as they look at the diversity of opportunities at the new place, when considering a job move. Some other interesting things that are not here, but they were related to flexible working hours and better work-life balance. We saw that men rated that slightly higher than women. So that was a little bit interesting for us as well. So over to you, Patrick.
Thanks, Shafaq. So just want to acknowledge all of our collaborators in the working group that helped support this work, as well as the ongoing support from the National Science Foundation for this and the related work on the RCD Nexus Center of Excellence. And so with that, we'd really like to reach out to you all, because I know you've got some groups working on these same kinds of topics, and we think there's some overlap in our interests and the questions we're exploring. We'd love to collaborate and coordinate. So in addition to questions, we'd really like to hear, what do you guys think is the best way for us to work together on some of these things?
Thank you very much, both. So first, so Patrick, for the question of collaboration, I think, we collaborate already well between US-RSE and CAC, but especially on this, there are more possibilities. I totally agree. Are there any questions? Please just raise your hand and put something in the chat.
I'll stop sharing so we can see one another again.
Yeah, that's helpful. Ian?
Hey, Patrick, Shafaq, thank you. It's great. I'm glad that somebody's looking into this so carefully. I'm curious if you've looked at other surveys, perhaps like Stack Overflow developer survey, and sort of how the RCD community compares to, what traditional software engineers outside of RCD. Are there things that we can infer about the differences between the two communities?
So the main thing we looked at there was we looked at a number of things. We haven't yet, I don't know, I'm trying to remember if we looked at the International RSE survey when we were doing this analysis. We looked at a number of them. In particular, what we were looking for is the distinction between sort of research related jobs and traditional enterprise IT. And we saw that, you know, many of the things that are cited for why people were motivated to resign or switch jobs during the pandemic didn't actually hold as much for the research related jobs. And that was the biggest distinction that we saw, is that where there were a lot of things that reasons that people were leaving jobs, they didn't hold as much for the research community. There's tons more work we could do there. And, you know, I think that would definitely be interesting to explore that further. And we mentioned some of those things that we looked at in the paper. But I think it would be really interesting to look at consistency of what other surveys in this domain are finding, like the International RSE survey.
Great, thanks.
I see somebody asking if the RCD community is the same as HPC scientific computing. We think that the RCD community subsumes, well, it includes, I don't want to subsumes, it includes that HPC scientific community, but there's a bunch of people doing things beyond HPC, ranging from cloud computing to a lot of social science computing that doesn't happen in an HPC environment, in digital humanities, a lot of data work that isn't necessarily closely tied to HPC. So there's definitely a very, very strong overlap, but we're struggling, to be honest, to be as inclusive as possible, because the domain of what people think of as supporting research with technology is really, really broad.
Thank you very much. And so Joshua has a question. He raised a hand, and that is the last question for now, that we can, you know,
Okay.
move to the next speaker. I think we can, you know, have discussions also offline,
Okay,
or in the breaks about the collaboration. Yeah. Joshua.
Just a quick one. So we know that how much these factors matter to people, but when we have things like, you know, how much is salary a factor? Do we know how much more salary people want? Like, do we know if it's like, oh, I would value 5% more, or I would value like 30% more? Because that might make a huge difference in how tractable that is to address.
yeah, that's a really interesting question. And no, we didn't explore it at that level of detail, but I do think that would be a really interesting thing to explore. How much difference on these different factors would make a difference? So that's a great suggestion.
Yeah, we can talk more. I think the DICE salary survey, if you've looked into that, does a pretty good job of breaking down things like that. That might be a close comparison.
And just quickly to Dan Gunter's question, yes, we looked at career stages. You can read about that in the paper.
Thank you so much for keeping it at that level. So of course you can also continue chatting and answering in the chat, of course. You know, so the Slack channel, if you want, you know, to discuss there. Okay, so thank you very much both again. Thank you for
Thank you.
Thank you.
So we go to the next speaker. So Caleb Jackson will talk about how to grow diverse and sustainable teams through mentorship.
Okay, so I'm Caleb Jackson, a software engineer at a software consulting company called Tandem, based out of Chicago. And today I want to talk to you about how developers best mentor early career developers. So for today's agenda, I want to give 2 disclaimers and then talk through my experience and highlight cultivating trust and practicing learning and experimentation, then wrap up with some key takeaways. So for my disclaimers, it should come as no surprise that my experience doesn't apply to everyone. So your mentorship techniques should be tailored to your mentoring relationships. And also, you don't necessarily need to hold the role or title of mentor to use these tips, because most people in this field like guide others in some capacity. So I hope whether you're officially a mentor or not, you can learn something from this talk. So to begin, my journey started by going to a conference called Lesbians Who Tech. And as a queer and trans non-binary person, I thought this was a great first conference to go to. And it was at that conference, I learned so much, but I was surprised to learn about DeepMind, which introduced me to the intersection of science and software engineering. And upon further exploration, I got very interested in this field. I began learning about open science and numerous ways that software helps to support scientific research. And as you might imagine, this led to many tags and feelings of overwhelm. Initially, I felt like having lots of options was a good thing. It meant I could choose to get involved in whatever I wanted. But still, there was a point when I felt like I was in over my head. And I felt pretty vulnerable admitting to not knowing where to begin or who to talk to or how to navigate through all of these ideas. And that's when mentorship came in. Mentorship provided me with a bunch of things like support, goal setting, advice, and especially direction. I was mentored by one of my coworkers, the tech lead on the project I was staffed on. And it was pretty informal, though our company has a mentorship program that runs for about 6 months, twice a year. It started with me talking about my interests in biology and software engineering. And I think she could just sort of tell from the times I would screen share or anytime I talked about open source projects that I didn't know where to begin. And because we were staffed on the same project, I had a hard time letting my guard down and fear of her finding out that I didn't know everything. So she was the tech lead on the project, and at some point she offered to be my accountability partner and sync with me weekly. And we called these things check-ins. And during our check-ins, we initially would talk about my career goals and interests, both work-related and non-work-related. And from those conversations, we came up with tasks for me to complete before our next check-in. So that was the mentorship dynamic I experienced. But one of the questions I think is worth discussing is the concept of cultivating trust. When learning about mentorship, you'll likely come across a bunch of different metaphors. And yes, I'm going to highlight one too. On the left, you'll see a sculptor working on on the left, you'll see a sculptor working on a sculpture, and being mentored by a sculptor doesn't really work for me. Sculptors tend to mold you into what they think you should be. For example, my mentor could have guided me towards becoming a better software consultant, which would have made sense because that's the work we do daily anyways, right? But on the right, you'll see a gardener. And I think my mentor took on more of the role of a gardener. She created a space, a virtual space, in fact, that encouraged growth, valued communication, and gave me a sense of belonging. And I think trust was built by her approach to mentoring. For example, she'd share some of her early career stories with me. She was also always open to questions, even DMs on Slack. Then one piece of advice I give to mentees is to openly ask or send your questions. I can definitely relate to feeling like I should already know this, or this is so obvious, but sometimes it's really not. You might be shedding light on ambiguity within documentation, and it's completely understandable that you don't know everything. And asking those questions will likely lead to you learning how to solve or look for solutions yourself next time. Now, with this in mind, like I said, my mentor was also always open to questions, including via Slack. And I recognized that she was open to questions because if she was overwhelmed by them, I never knew of it. So that brings me to my next point of setting expectations. It'd be best to do this during your initial meeting. Now, admittedly, our first meeting wasn't very formal because we had already built a level of rapport from working together on work-related projects. And our projects at work usually began with project kickoff meetings where we'd share our personal guides to one another. And these meetings seem awkward or somewhat unnecessary to me initially, but I think they're pretty valuable in getting to know your team. These questions specifically highlighted in the blue box would be great starter questions between mentees and mentors. How do I most comfortably communicate with others? Am I cool with impromptu calls? What qualities do I particularly value in the people I work with? What makes me grumpy at work? How will my team know if I'm grumpy? Now, of course, these should be tweaked a little to fit more of like a conversation between a mentee and a mentor. So you might say like, how will I know if you're grumpy at work or something like that? Now, I must add as well that mentees, this might be your first time thinking about questions like this, which is okay. Plus, the answer to these questions might change over time, right? I know I especially noticed that within myself. But what also helped me with building trust was the main thing that did stand out to me during our first meeting. My mentor just seemed just as curious and as excited as I was about my interests. Then during our check-ins, she would phrase questions like, how does that sound? Or do these tasks sound doable? Which made her seem open and understanding. Now, of course, I would often say, I can do this. Then the following week, not actually have those tasks completed, right? And my mentor could probably tell that I bit off more than I could chew, but allowed me to see that for myself, which is really important. And she reminded me that there's not really a rush, like whatever pressure I felt was self-imposed. And those learning moments tie into this next part of practicing learning and experimentation. Like I said before, I was pretty overwhelmed with all the options out there for me to get involved. And mentorship especially provided me with a sense of direction. One practical artifact that came from mentorship was putting all my ideas into a document and then dwindling down which projects interested me the most or seemed most doable. For example, I weighed the pros and cons and found lab.js to be really cool, but it didn't involve much coding, so that didn't really work for me. So I decided to learn more about JS-Psych, which is a JavaScript framework for building behavioral experiments online. Now, why does all this matter? Remember again, I started with feeling overwhelmed by my options, and having a mentor that I trusted and who encouraged experimentation gave me more confidence in my JavaScript skills and my ability to get things done. I remember, for example, after digging into JS-Psych and building 2 or 3 practice projects from the documentation, I decided I wanted to use JS-Psych to build a shoot task experiment. And even after building it, I came back the following week feeling like I didn't accomplish enough. Because I realized in order to save the data from my experiment I built, I needed to learn some other tool called cognition. But my mentor reminded me that I took an idea or an interest and created something from it, which is worth celebrating. And having a mentor helped to remind me of those achievements when I couldn't quite see them for myself. And to wrap up with some key takeaways, just as a reminder, my story doesn't apply to everyone, right? And this talk didn't discuss mentorship programs because I think informal mentoring is really effective as well. And on the right, you'll see a word cloud with qualities of a good mentor in the shape of a plant to remind you to take on the role of a gardener. And when it comes to mentorship, to take on the role of a gardener when it comes to mentorship. But on the left are a few points that I wanted to highlight the most because of the impact they had on me. If my mentor wasn't initially observant, I doubt she would have reached out to me and asked to mentor me. And I probably wouldn't have reached out to her for help either. I'm not really sure. And I think our weekly check-ins played a key role in building trust. As I mentioned, I really appreciated when she shared her early career stories and how she was never visibly like flustered with all my questions. And if you know too many questions might overwhelm you as a mentor, that's why the setting expectations part is so important. Lastly, celebrate mentees' accomplishments, no matter how small, because reassurance really helps with confidence building. So.
Thank you so much. Oh, sorry.
I think, I think next is like the Q&A portion.
Thank you very much for a great talk. So yeah, I see a hand up. Oh, I see clapping. Okay. This was not raising hands for questions, but yeah, please ask questions or put it in the chat. So many thanks for your personal experience there. You know, that is really, that is very valuable to see that. Yeah. So did you get feedback also from, let's say, managers or other managers or, you know, giving your opinion about this?
Yeah, so or like for this talk specifically or during like my mentorship?
Oh, when you talk about this topic, because you seem to, you know, be really engaged in making mentorship better.
Yeah, for sure. My managers were pretty like supportive throughout all of this. Even though I feel like, of course, like, you know, at work you should focus on, you know, completing tickets and all that. But again, that like taking on the role of a gardener and not like pushing me to be like a better, like pushing me to just be better at this job. I feel like that was like really, really important because I felt really open and like safe to explore my own interests. So yeah. I
Fantastic.
think Jamie has a question.
Yes. Me?
Yeah, I'm going to throw a question. So first of all, thank you for the talk. I think that mentorship is critical, but there are many buts. So first of all, it's time consuming,
Mhm.
and it needs skills and also personality. I've seen some people that are very good with some mentoring some people, but terrible with some other people. So can you provide any idea how to balance these things?
Yeah. The first thing that comes to mind is like that piece of sharing early career stories or like sharing your stories with your mentees, right? And having mentees share their stories as well. Because I feel like that will build up like a level of like rapport and like trust among the mentee and mentor, as well as just like, I don't know, like sharing interests. Because whenever you feel more comfortable with the person, I think that helps with the relationship a lot. And even if you are like kind of an awkward mentor, that could be like your, you know, clerk or whatever, and your mentee could be more understanding of that.
Thank you.
Yeah, thank you so much.
Awesome. I
So
really appreciate that.
there is also comments. So those discussions can also help you decide if someone should or should not be your mentor.
Yeah,
Exactly.
yeah.
I would agree to that. I was part of a program, for example, where it was like, you know, bringing the two groups of mentors and mentees together, and then people could discuss through a duration of 2 hours. That worked well for people finding maybe more suitable mentors for themselves.
Yeah.
So, okay.
Yeah, I really appreciate the keynote speakers talk and like the piece where he was talking about like going to the places where there's underrepresented folks, because like that's sort of like what I experienced as well, with, you know, being raised a Boys and Girls Club kid, and things like that. So.
Great. So thank you so much again. Thank you for a great talk. And now we are going to the next talk. And that is by Fang Liu. How to turn women in HPC to future RSEs, activities in the WHPC GT chapter.
Yeah, okay. So yeah, I'm so enjoying in this session so far. So everybody did a very good presentation and in depth. And I know some people already have a paper for this presentation, but for this presentation, it's basically, it's not paper existing yet. It's more like some information sharing among the community. And I want to read some discussing on this topic. So my name is Fang Liu. I'm senior research scientist in Georgia Tech, and also I'm lead research software engineer in the PACE team, which is HPC Computing Center in Georgia Tech. Okay, so for this talk, I'm going to cover the history of this WHPC chapter in Georgia Tech. So this chapter was established in December 2020. So this year we almost has 2-year history so far. So I want to share some activities happened so far. And I want to read some discussing how we can inspire young women into the HPC field. And I'm sure there's a connection between HPC software engineer to the research software engineer in some way. And I hope this can increase some collaboration as well. Okay, so what is WHPC GT chapter? So actually the WHPC was an international initiative actually from the University of Edinburgh. So they did a great job to set up this volunteer-based organization. And there are a bunch of US institutes have established their own local chapters and those organizations. And especially you can see the ROC and the Purdue University also has a chapter there. There are also some other chapters from Texas also there. So when we set up this chapter in Georgia Tech, this is a set up the role we have originally. So the general idea is inclusive, include the inclusive, and to include more and represent women into the field. And particularly that's our goal for our chapter. So first of all, we're trying to help students to build their HPC professional career paths. And also because we are in PACE, we have a large cluster and computing resource. So we also trying to provide some resource for teachers on their courses, and then offer some helps for the teacher. So right now, we even can offer the computing resource to individual students if they have a proposal to well-define their projects. We can give even students access to the PACE cluster so that they can explore some HPC skills on the campus computing resource as well. So the last one is involve industry partner. So that's also goal. Here I like to introduce the leadership for this chapter in Georgia Tech. So I'm the only full-time people in this group. So and leading this our chapter, and the rest of the girls are all students. So you can tell we have 3 PhD candidates from computer science and computational science and electronic engineering and earth and atmospheric field science. So they're from different area. And we also have some undergraduate students from electronic engineering department. So, so basically, yeah, they are students, they are working on their volunteer hours, and somehow, you know, you cannot expect much from them. But we actually work together in the past 1.5 years. So we end up to deliver like 3 great success events. So, and yeah, let's go to the next page. Yeah, so the first event we had is a debate event was last year. So when we first created in December 2020, so we prepared for the first event for almost 4 months or 3 months there. So in that event, we actually invite all 3 well-known female HPC researchers nationwide. So they are here's the name of them. So for that virtual panel, we basically want to have people to share their personal journey, like as a woman leader in the field, how they get in, what they could ask, and raise some, so allow students to ask questions. So actually we did pretty good because that's the first time we have the event. So we had 40 participants. Actually, that's nationwide, not just Georgia Tech, and we received quite a amount of questions. And also there's a lot of students ask us, so if I want to go to route, or which course I have to take, something like that, those questions. So that was the first event we hosted. So let's go to the next page. So, and then in the second half of the year, we prepared this second event. So this event takes about also three months to prepare. So for this month, I was trying to say, okay, since they know the people's career path, next time, let's focus on what kind of HPC type of research could be looks like. So then we invite 3 faculties from the Georgia Tech. They are all from Georgia Tech College of Computing, and all women faculties. And they join the session, and each of them give the 50 minutes presentation and their research. So actually they go very deep in their research, what they're trying to do and what they have done, something like that. So, and then we have some interactive question and answer as well to ask them. That's more technical oriented way. But this one is because different professor has different research area, so they only maybe the overlap of the topic maybe not that much overlap, but we still receive quite some of the questions for each professors. And this is, and we have like a 15 attendees. Actually, this attendees is a very broad spread all over the world. So we have like people from 4 countries and 15 states in the United States, states inside the United States, people coming join on this event. So this is the second event we have done. And the third one is this April. So the third one, we're trying to say, okay, now let's give some chance to students to show up their research in related to the HPC. So we send out this call for proposal thing. I think this one takes about 2 months to prepare, and we get quite a bit submissions, and we do some selections based on some criteria, and we select 10 posters, and a majority from Georgia Tech students. And surprisingly, we see a couple of them from Lawrence Berkeley National Lab as well. And actually in this format, because this is all for virtual, so we just give each student like 5 minutes presentation on their poster. And then we have like 2 HPC experts from pasting and serve as judge in the real time for the poster. So that at the end, we have a score for each poster, and we get the best poster award at the end. So we have 63 attendees for this event. And at the end, I think those young women is very excited because it's more like a party thing. They just very excited to discuss, and each poster raised some questions. So I think it's more like they kind of find the people with common interest in that event. So that one also, actually the one leading this event is the undergraduate, the students from the leadership. So that student also very fulfilled about this event because she wasn't sure she can do that, but at the end she found out, oh, this is a good accomplishment at the end. And right now we are working on the next event, which is, okay, can we go to next page? Yeah, so next event we target for next month. So this one, for this event, we try to target with the audience or students. They have some C and C++ background, but no any MPC, MPI programming experience. So we want to target to those students, and the format like for this hackathon is we will have like a 1 week long boot camp, by each day just 2 hours lecturing and some exercise, and then the hackathon will be over the weekend, so there'll be 32 hours of hackathon. So that's something we are currently preparing for, and so far we haven't sent out the call for participation externally yet, just within the Georgia Tech, but we are soon to send out that. So basically so this is what we are right now. So while we trying to build up those event, the goal is, I think we want to help you to raise some awareness about HPC. So in Georgia Tech, we have a large amount of students who studying computing science. So College of Computing and the College of Engineering has a bunch of computer science and computer engineering related major students. So we have a lot of students, but in the computer science field, it is very diverse. So people focus on the HPC or focus on the computational science, still a very small group of them, and women are even less in that group. So, and also currently, actually, we're working with there's a student organized group called the Supercomputing at the GT. So it's a student-led organization, and they also trying to build a club so that for people who are interested in this HPC related coding work, they can work together and to raise more, to include more people to that. Okay, can we go to the next page? So yeah, this is quite challenging. So the first challenging thing is it's very hard to find leadership members. So it took me half a year to find those 5 girls who was interested to serve in the committee and to help in the chapter. So I would say this is a volunteer job. So we cannot expect much devotion from students. So that's also something you cannot say, give him a task, give them task and ask them to deliver something to you in certain time frame, right? And also it's very time consuming to organize the event. And this is sometimes more like a full-time job to really organize and send an email to do reminder and to prepare everything. So it's more like it's external from what is real HPC professional people supposed to do. So then the sustainability is become a question. So can next people take this away and continue to do the same thing? That's still the question. So I'm thinking like right now we have different chapters in United States. So I see the Rocky Mountain chapter. I think they did a lot. I'm on their mailing list. I received. I know they're doing a lot of good work around invite people to give talk and talk about grant renting, and also the chapter from Purdue. They're also doing something to introduce the people, distinguished people to give talk. But overall, I don't know if just invite people give talk. Well, that really does the job to inspire the young women getting into the field. So maybe I think it's more like we have to make the goal particularly very specific and then developing plan around it. So that's why I want to have this event. I more want to do a student central thing and to make awareness. But I think that's far below expectation. So I'm just somehow say, oh, I don't know what I can do next. Sometimes just like say, what is the evaluation we can use to say, oh, this is a success, or this is something you still need to improve. I just like say, if some other units interested to say, oh, we have same issue, we want to solve this same issue, maybe for the event, we can do it together. And I think it can save a lot of effort and make some contribution together. Yeah. Yeah, I think, yeah, that's our website. So if you're interested, feel free to go there to check out any future event. Thank you.
Thank you very much.
Mhm.
Thank you very much for a great talk. And so as before, questions in the chat, or raise your hands. So I see some clapping. So there's from David a comment. Oh, Helen has her hand up. Helen?
Hi there. Great talk. I don't have an answer to this, but I guess I've just got the question. I see a lot of women in HPC stuff where it's women doing the work to get more women. Is there anywhere to encourage more non-women to take up some of that load? Because that's quite a heavy load on women already trying to further their own careers.
Yeah. So when we say we are women in HPC, we don't preclude men from that event. So everybody is welcome. Actually, the post event we had recent in April, actually there's one presenter was men, and that's okay. So we just try to encourage more women to apply because women is underrepresented in this field right now. So I remember when I joined the team in PACE about 10 years ago, I was the only woman in the meeting room for almost 3 years until the next woman joined the team. So I just feel like, yeah, maybe we can encourage more women to the field. So that's the main goal. But we don't pre-recruit any men. That's the mindset. Yeah.
Thank
I
you.
think Caleb has a
Yeah,
question.
Caleb.
Yep. I was going to ask about the, you had mentioned that y'all hosted a boot camp or like a hackathon type of thing. Did you have a lot of, with the boot camp specifically, you said it was like 2 hours every day for a week or two? I don't remember exactly. Did you have a lot of
Oh, the
buy-in
book
with,
camp.
yeah.
Mhm.
Did you have a lot of buy-in with like students actually coming for every day?
Oh yeah, this
it's
is
like a
our
commitment.
first time. Yeah, this is our first time. So
Okay.
yeah, we don't know yet. We'll see.
Oh,
We'll see
okay.
the data
Okay.
afterwards. Yeah. So
Gotcha.
I was expecting, like, say, we will have like at least a 2-person team. If we
Mhm.
have like less than 10 team, that would be have quite a good size for us to handle. You know, because
Mhm.
we have to set up accounts and on the local cluster and for them to use, and especially the training part. So the 2 hours per day for 5 days in a row. So we just tailor this training material around the people who has a basic program skill but no MPI. So then and introduce some parallel programming ideas and give them the task case and let them go from there for the hackathon. So that's the plan.
Gotcha. Yeah, I didn't realize it was like in the future. I thought you did that already.
Oh yeah, that's it.
Thank you.
Yeah, just next month. Okay, thank you. So we know there's a lot of fields in computer science, just like I said, you have data analytics, there's AI, and there's a lot of different type of hackathon. So some people sometimes, like Levita say, we have an HPC hackathon, but actually the people don't have to deal with any MPI at all. They just let code automatically run on the multiple GPU or like those. So I think for people to really understand HPC, maybe we should start with the basic. To write some code with MPI, so you understand how internally the job scheduling, how the job was divided, and how to take care of the large size of data sets if they're bigger than memory, something like that. So that is more like a training. It's not like for hackathon's sake of hackathon. It's more for training purpose. Yeah. Hope, and at the end of that 1 week, I hope students raise their interest to learn more things in HPC world. Yeah.
Thank you so much again. I think these were the questions for now. Thank you for a great talk.
I'm Dan Katz from University of Illinois, one of the steering committee members for US-RSE, and we will go ahead with a talk from Henry on, well, I'll let you introduce your talk, Henry.
All right, thank you. So, there was supposed to be actually sort of like a best practices from R, but we missed out on that one. But I'll be talking about best practices for Python packages, focusing on sort of how you work with binary Python packages, which is something interesting to us more than some. And it's definitely a little bit more of a challenging problem, but one that I've worked on quite a bit. So I'm part of the Scikit-HEP project, which is focusing on building sustainable software using Python. It's funded by the IRIS-HEP grant and other sources, but it's been around since 2016, and really started collecting a lot of different packages from different areas that were focused toward high energy physics. And by roughly 2018 or 2019, somewhere in that range, we started. We ended up with dozens of packages. Several of these needed to build things because we were interested in getting good performance. You know, collection of these packages were compiled. So that's sort of the diagram that you see here on the right. A lot of the things on the lower shell there that's just above the built-in things like boost-histogram and awkward, which is there, are things that needed to be built. And so we've done a lot of work on building up the tooling and on education around how you build and maintain this. And we do this over quite a few different packages. So just to give you a quick view into the Python packaging ecosystem, this is a timeline. So packaging sort of has been changing over the last few years. Originally, there was a utility built into the standard library called distutils, and then that was insufficient. So then setup tools was built to wrap distutils, basically extend it, and the entire thing just became more and more difficult to maintain. And it turns out it's a really terrible idea to put packaging into a standard library, because the standard library doesn't change and packaging involves the internet, and you're downloading packages from servers and things, and that does change, and building and compilers and all that stuff changes. So around 2015, a PEP, or Python enhancement proposal, was introduced to add to allow the packaging ecosystem to no longer depend on just one special package, as well as special hacks built on top of that, and instead sort of open this up and provide standards that people could write and could follow and build any sorts of systems that they wanted. And this has continued with some other advancements for the last few years, but we're really talking about something that started in 2015, which was packaging is an area where you really have to think about history, because you don't know what people are going to be actually installing your package on. And so a big change is coming up here soon, as well as Python 3.12 will be removing distutils from the standard library. That was proposed in PEP 632 and is going to happen next October. And so this is sort of shaking up the binary building ecosystem, and things are coming along to sort of fill the gap. I'm working with Scikit Build, and I have a grant to work on that over the next 3 years. I'll mention that as we go. So just to show you what Python packaging, if you've seen Python packaging, you've probably seen a lot of examples that are not really ideal, or how we do things in modern times. So this is really what packaging looks like today. So with the 6 lines that you see on the left, not counting the comment there, those 6 lines are enough to create a package you can build. So if you add the 6 lines to a file called pyproject.toml, you will have something you can pip install and work with. A little bit more recommended than that, but that's the bare minimum. You don't need a setup.py, you don't need manifest.in, you don't need setup.config, you don't need all of these old classic files. You don't have to learn different syntaxes and various things. You just need this one, and a toml's fairly standard syntax. It's used in Rust and other places too. So this for pure Python packages has been absolutely fantastic. Things have been moving over, especially to Hatchling. Hatchling has really been Hatchling joined the Python Packaging Authority a few months ago, and it's been getting plugins. Fast API just moved over, I think, yesterday. Lots of things have been moving to this, and it's really, really nice. But if you want binary extensions, currently you still kind of have to fall back into this old setup tools, distutils mess, and that is changing them. One thing that I worked on was rewriting the official Python packaging tutorial to use this system. It was a 6-month project. Most of the 6 months was spent discussing this box that you see here that lets you pick between the backends. But I really wanted that because it shows how much you just need to change those 2 lines. You can just flip the tabs and look. Everything else in the tutorial is identical, and that's really a benefit of this PEP 621 standardized configuration that all the backends can use. So all the rest of the page stays the same, which is really nice. And this is actually everything you need as far as configuration to have a nice project today. Okay, so setup tools now supports this, and it's quite nice. But again, this is for pure Python. So this is sort of the components for building a binary package. You need something to create, something you can call in Python. You need something to build this into binaries, and then ideally you distribute binaries, and for that you should have a redistributable wheel builder. And we'll follow this particular path because it's the one I'm involved in. If you're interested, say in Rust, the PyO3 path there is a really good path as well, and it also has its own builder, which I didn't list there because it's not only specific to Rust. And yeah, but you can mix and match. You can use Motrin, or, well, I guess Motrin is for Python. You can use Meson.py, for example, instead of Scikit Build. So PyBind 11 is a header-only pure C++ interface to the CPython API, which happens to work for PyPy as well. And by header only, it's really trivial to add to a project. There's no special build requirements. And by pure C++, I mean that you don't have to add any dependencies. You don't have to run this through a precompile phase like Cythonize or Swig or something. And it's not a new language. You don't have to learn how to write a new language. Cython is an example. So this is an example of a very simple PyBind 11 program, and you can see it's just 7 lines there. And that includes the code you're trying to wrap. And I also include the line you would need to compile this, and that will give you something you can import and play with in Python. In Linux, and you can do a slightly different one line for macOS. Here's a slightly more advanced example, just to show you that you can do things like names, and you can throw in Lambda functions, you can set properties, you can do all these sort of advanced things quite nicely, simply, and really just learning some little bit more advanced C++, but not learning a new language. And it's got all sorts of really nice features. We've got over 700,000 mentions on GitHub, and we don't require NumPy to build for NumPy, which is fantastic, because there's lots of caveats to requiring NumPy if you have to use it at build time. Okay, and we now are running in PyDot. We support WebAssembly. We've done lots of different things with PyBind 11. And just to quickly mention, there's also a package called NanoBind. It's from the original author of PyBind 11. He's still involved with us a bit, but he went and rewrote PyBind 11 again. PyBind 11 itself is a rewrite of Boost Python. This is designed really to do very small, efficient bindings. And it has much higher requirements than PyBind 11. A few tips for best practices for this. Really, I would highly recommend avoiding the CPython API itself. It's going under changes, and it will go under more changes. The faster CPython project, which is fantastic. It's the reason that Python 3.11 is 25% faster on average and 60% in some cases. That is causing API changes, and it will continue to. And using a layer in between that is really helpful. The core devs are suggesting that. A wrapper can help you with that. PyBind 11 and all these things will update for those changes. And your wrapper code is code 2. Don't settle for something that's not ideal. If something is not ideal, improve it. We've gotten involved, and we've been very involved in improving lots of these different things in PyBind 11 to make sure that it would meet our expectations. And then make sure you test pre-releases of Pythons, for example. Now, scikit build is an example of some way to build it. Now, traditionally, it did this sort of mess where you have setup.py, which is sort of this dist-util setup tools thing. And then scikit build just sits as one extra layer on top of all of that. So you still need your manifest.in and your setup.config and a pyproject.toml. You still need all of these different files. It's currently being rewritten to be scikit build core and scikit build core. And that will just have a PEP 517 builder, and then that interface will be used to provide sort of the class, to replace the classic interface as a setup tools extension. And we're also discussing with other Python packaging authority people, we're discussing writing a PEP to handle general extensions. So a PEP 517 builder could call any extension system you want. We could just tie into an existing builder, which would be very, very nice. And so and we're trying to sort of modernize this. This was actually part of a grant, SF grant that I'm part of. Rewriting it is the first year. Second year is really focused on some of our collaborators, helping them move over to using scikit build and using the new scikit build. Third year is really focused on documentation and training, as well as some tutorials, including some partnerships with US-RSE. And this could include really touching a variety of different packages, not just the scikit build itself. So a few tips for this area. Definitely watch the space. It's a bit challenging today, but it is getting better. And try to provide binary builds. We'll talk about that in the next slide. But if you provide a binary build, then your user doesn't have to do the build themselves. So they don't have to worry about if how you build or not. And try to stay fairly simple, just so that you're prepared for changing and updates. you try to add don't add things you don't need if you can avoid it. Just a quick mention on build, which is the build front end. There's lots of examples out there that show this: Python setup.py sdis, Python setup.py bswheel. That doesn't work if you don't have a setup.py. You're just running Python, and it's got all sorts of issues. Like you can't tell it what you depend on if you're just running a raw Python file. So this is replaced by build. So you can use I like using pipex, but you can use whatever you like to use to run Python, and you can use build, and that will build sdists and wheels for you, and it'll activate these build systems. In fact, I show you how you would add this to GitHub Actions in a few lines on the right. I really love that GitHub Actions has pipex as a supported package manager. So CI build wheel is a tool that we at Scikit-hep, we actually developed our own set of build scripts called the Zero Wheel Helpers, and then we found we were monitoring the CI build wheel project. We finally decided the remaining things that we needed we could just add. We did. In fact, we joined with them, and now that's used to do all the builds within Scikit-hep. And we actually pushed to get this into the Python Packaging Authority. It was accepted in 2021, and it's done quite well. It has a variety of different features. You can see over on the right, you just need a very simple GitHub Actions workflow, and that will then build all the common wheels that you might need. And it's quite useful. It's not tied to a particular one. Here's a few of the packages that have moved over to using Scikit build over the last, moved over to using CI build wheel over the last year or two, and very happy that we now have quite a few users. And one thing that this has helped, if you've noticed, NumPy's on here, and they released Python 3.11 wheels a few days after the first RC came out of Python. That's never happened before. They've always released after the first full release, and that's because CI build will enable them to do that. So key tips here: redistributable wheels. I would recommend using a system like CI build wheel. In fact, I specifically recommend using CI build wheel. With CI build wheel, I would use the static configuration as much as you can. There are ways to configure this directly in your environment files, but it's better if you do static configuration, because then you're not tied to your CI provider. That stays a very simple script, and you can run things locally. And I highly recommend using Dependabot. One of the reasons we provide an action is that Dependabot can then update that for you, and you can have something just automatically update. That way you don't break right before release. All this comes together in the Scikit-hep developer pages, which is something that we built up over the last few years, and sort of describing all of our recommended best practices. In fact, we're in talks to try to move this over to make this the scientific Python developer pages. And this includes guides on how you do packaging, both the classic style as well as the simple style. The style guide, which lists all sorts of different things, like how you set up type checking and black and placate and pylent and cling format for C++ and various things like that. All this is done through pre-commit, so it's very easy to run them, and they all run in isolated environments, and it's very fast. And as well as lots of other guides, like for how a guide in static typing, things like that. This includes a cookie cutter, which allows you to, once you've learned everything in the Scikit developer guidelines, you can then just quickly make a package that follows all of that. And we have a repo review tool, which is both a inline inside the developer pages and runs in WebAssembly, as well as a command line application that you can run. And that will tell you how close you are to following the guidelines. The cookie cutter has 11 different backends. So it'll just ask you what backend, and it could be setup tools, Flit, Hatch. We even support Poetry, as well as some of these compiled ones. So this is one of the few cookie cutters that actually produces compiled results. So I've got some links there you can follow. Definitely take a look at our developer guidelines. Take a look at the repo review. It looks like this. You can just type in a repository name and a branch, hit the button, and it will be running Python in your browser, locally in your browser, like in your actual browser, not somewhere else. Downloading this from PyPI, and then giving you a report. This has actually already been used by some other physicists and RSEs to add their own web pages. They've been following this as sort of a guideline, so you can see the TRIPE-IHF page there. So that's been very successful. All right, and that's what I had. And I think my daughter's awake.
Okay, thanks very much, Henry. Do we have any questions? I guess we have another minute or so before we end
I
officially.
can answer questions in a second. I'm just going to go grab my head.
Okay. All right, so I see one question in chat from Dan, which we'll ask when Henry gets back. And one from David that'll be next after that. And maybe we'll call that the end of the virtual workshop for today after those two.
Okay, I'm back.
All right. Yeah, so Henry, so we have one question in chat. I don't know, Dan, if you want to say that, or Henry, you just want to read it?
Okay, so someone asked if this plays well with PyInstaller. Or is there a different stack? That would be a different, I would recommend that usually as a component, depending slightly on what you're targeting. So that would sort of be, so in the, no, don't leave. So in this, so that's sort of showing this diagram, we're showing the different paths through. That would be a different item on the last item. So if you're producing an app, you're not really, if you're also building a wheel, then that would be another, you just have another sort of target here on the top far right. If you're only producing an application, then the packaging story is a little bit different because you're not trying to distribute this as a module you import. But some of the ideas still apply.
Okay, and then Dave.
Thanks, and thank you, Henry, for the talk. Actually, my question was for your daughter. Can you bring her back? No, I'm just kidding.
She just left.
I love everything you're doing. Really appreciate it. I just wanted to ask for, so like I'm developing an extension for PyTorch, and right now their example is use a setup.py in combination with PyBind 11. So can you just say a little bit about like where you're at with scikit build? Can I test a new version that does not require the setup.py now? And how can people like give you feedback? And
that is coming very soon, but not yet. So I've started working on the rewrite. Technically, I was originally supposed to start, I think basically in September 1st, but I've also started teaching a class. So my percent time allocated is lower than expected. So there is if you know where to look, you can find scikit build core. I'm currently working on getting the wrapping the CMake working right. So I'm working on getting a file API going. So the new one will use the file API to communicate between CMake and the builder, which will allow it to know what it's doing. So the PEP 517 interface is not hooked in yet, or it's not available there yet. But I would expect within, there might be something to start experimenting with within basically probably around a month or two. And at that point, I would love to have people who are interested in just playing around with this and trying it out, and just do it sort of as a test and a PR. Don't actually depend on it quite yet. But I would like to see sort of what people see, and if it looks easy to use. And then I'm going to be I'm going to become, I'll have the curse of expertise at some point, and I need people who don't have that, who aren't cursed with that.
Well, I definitely don't have any expertise, so I'll start watching the repo and look for that PR.
All right. Well, thank you again, Henry.